cool. Oops. Yes. Okay, I start with the MC question. So if you got any problem what I am explaining that, so just type in your question or just stop me, unmute yourself and ask me, okay? So the first one, the question 3, okay? So I highlight this one because many of you made a mistake. Sorry, that's not the first question. Okay, so first one here. Okay, so I highlight the number. That means quite a lot of you made mistakes for that one. Okay, so let's take a look together. So for this one, the question asks you, in the following cases, which one will the iron nail corrode fastest? Okay, so you need to find the fastest one among all 4. Okay, so recall your memory when we learn the rusting of iron. There are some conditions that can speed up the rusting process. So first, we can dissolve some ionic compounds, so provide some mobile ions in the solution, so that will speed up the process. And also the temperature would have an effect on it. And there are some conditions that we're going to mention in this question. So first, let's compare A and B. Okay, A and B, the only difference is that in A, we use this one, which is ethanol. So later this year, you're going to learn how to name organic compounds. So that's an organic compound, ethanol. And as mentioned in the hint, that's a covalent compound. So by adding it to the solution, it will not provide any mobile ions. But on the right-hand side, for answer B, sodium nitrate, that's an ionic compound. So when it dissolves in the solution, it would provide the mobile ions. So if we only compare A and B, we could work out that B would rust faster than A. Okay, and then let's take a look at C. What will happen in C? Okay, again, if we take a look at the solution, we still have 1 molar sodium nitrate solution. So again, this solution will provide mobile ion. Okay, so that can speed up the rusting process. But this one, it also connect the nail to the copper rod. Okay, and if you still remember the reactivity series, then the iron is more reactive than copper. Okay, so by connecting it, although through a wire, it will still tends to lose electron to copper because iron is more reactive. Okay, so this one, you would be, and it's a complete circuit, so you can assume there are some electrons gonna move through the iron to the copper. Okay, so again, when iron lose electron, it start to rust. Okay, so this one, 2 factors that speed up the rusting process. Okay, so C would rust faster than condition B. Finally, let's check answer D, this one. Okay, if we compare C and D, the only difference is that for D, we further add this battery. Okay, so for this 2, you're gonna learn in detail in grade 11, but here you can still have some idea for that. Okay, so if we connect a battery to it, actually we kind of provide a power or a driving force that sends the electron. Okay, so we know for a battery, the electron is gonna flow from the negative pole to the positive pole of the battery, right? So we can draw the flow of electrons on this diagram. It will have electrons sending out from the negative pole, and hence the electron should come in from the positive electron. Okay, so how can we get those electrons to the positive pole? Okay, that's from the iron nail. Okay, so besides, iron will lose electron to copper. Here, this battery further provide a driving force or a pulling force that gets the electrons out from the iron nail. Okay, so for the condition D, there are 3 factors that speed up the rusting process. First, we have this ionic compound in the solution. Okay, speed it up by providing mobile electrons. And then iron is more reactive than copper. Okay, so iron will lose electron to copper. And finally, the battery gonna pull the electrons out from the iron now. Okay, so the answer should be D. Okay, that's for the first one. Okay, a little bit challenging, but still okay. Okay, next one. Tin plating is used to prevent iron cans from rusting because, so you need to remember on your notes, there are several surface protection methods that we have learned. So tin plating is one of them. Okay, so if we are talking about surface protection, we mean that it covers the whole thing with a thin layer of that type of metal. Okay, so here, the main reason is that tin layer prevents iron from exposure to air. Okay, so it should be B. Okay, and next one. Okay, so 23. There are two statements, so we need to look at the first one first. During anodization, the aluminium oxide on the surface of aluminium is reduced to metal. Okay, so remember the process of the purpose of anodization is to thicken the aluminium oxide layer on the surface. Okay, so the process is actually turning aluminium into aluminium oxide, not the other way around. So the first statement is wrong. Okay, it's false. So it should be okay. And then let's check the second statement. The corrosion resistance of aluminium can be enhanced by anodization. Yes, because after anodization, the aluminium oxide layer has been thickened, and aluminium oxide layer is impermeable to oxygen and water, so it would prevent aluminium from corrosion. Okay, so the first one is false, the second one is true, so you should choose C for this one. So any question for this page so far? If no, just typing okay or no problem, and then I'll move on. Okay, so next page, question 5. Okay, this one pretty straightforward. A gel containing sodium chloride and the thing in the middle, and then phenolphthalein, which is in yellow in color. And after some time, which color will not be observed? Okay, so sodium chloride, as stated in the hint, it provides the mobile ions. And the thing in the middle, that's the rust indicator. And again, we have phenolphthalein. Okay, so what we're gonna be able to observe is that we should see the yellow color, that's from the rust indicator, the blue and pink color that shows the rusting of iron nail. Okay, so only gray color that we would not be able to see. So that's quite straightforward. It should be C. Okay, and then next one, question 7. Consider the following setups, which hook would corrode first. Okay, so for this one, you can see it's not covered. The thing covered the surface of that thing. It's connected to another piece of copper. Sorry, another piece of metal. Okay, so we need to look for one if it would corrode first. That means it's connected to a less reactive metal. Okay, so it tends to lose electron to that piece of metal, and hence the corrosion process would speed up. So take a look for answer 1. Aluminium is more reactive than iron, so actually that's sacrificial protection. Number 2, copper with iron. Copper is less reactive to iron, so iron would tend to lose electron to copper. So second one, yes. And let's check the rest too. Okay, and aluminium with copper. Aluminium is more reactive than copper, so again, sacrificial protection. Last one, iron with copper. Iron is more reactive than copper, so again, as a way to protect copper from corrosion. So the correct answer should be B. Okay, only B, that copper is less reactive than iron. Okay, I think this too is pretty easy, so I will just move on. Okay, this one. Again, we got a minion, okay, stating that this question is going to be a bit challenging. So for this one, the diagram below shows 3 ionols of the same size and shape, each immersed in a liquid. Okay, so first one is in 1 molar silver nitrate. Second one in 1 molar zinc nitrate. Last one in pure water. Okay, so, and you need to note that for all of them, you're gonna expect some of the oxygen that dissolve in all solutions. So that factor doesn't really affect your answer. And then we need to consider how can we speed up the process. Okay, so as mentioned in the previous question, if we have mobile ion, the roasting process is going to be speed up. Okay, so from that point, we could know that would roast the list. Okay, because it only got water and no mobile ions. Okay, so we should choose from A and C. Then how do we decide, is it A or C? Okay, so we just need to compare these two. Okay, so let's take a look what's gonna happen. Okay, so both of them are ionic compounds, so it will provide mobile ions. But take a look in X, when we put iron in it, we're actually putting iron into a solution that contains silver ion. Okay? So we have learned if we put a more reactive metal into a solution that contains less reactive metal ion, a reaction called displacement reaction gonna take place, right? Okay, so for this one, it's gonna turn into iron 2 plus silver metal. Okay, so the silver metal gonna deposit on the nail surface. Okay, and as stated in the equation, you can see there are a lot of iron 2 generated through the process. So other than the mobile ions speed up the process, for this one, the displacement reaction also speed up the process because it generates a lot of iron 2 here. Okay, but if we take a look at what's happening in Y, we have iron and we have zinc ion. Okay, remember the reactivity series. Zinc is a more reactive metal than iron. So when we put iron now into a solution contains zinc ion, actually no displacement reaction can take place. Okay, so no further process to generate iron 2 plus. Hence, the roasting process will not be speed up through the displacement reaction. So if we compare X and Y, X gonna roast faster than Y. Okay, so that's the reason we choose A, okay, as the correct answer. Okay, are you still with me? Okay for now? Okay, so if we move on to the next one, which of the setups shown below can best be used to anodize an aluminum object? Okay, I saw your message, okay. So back to this question. Anodization. Again, the detail of the process we're going to discuss in grade 11. But here, I want you to remember if we do anodization, we connect the aluminum object to the anode. And the anode in this case will be the positive electrode. Okay, so when it connects to the positive electrode, so we should only choose from B and D. Okay, so for now, I want you to remember aluminum object connect to the positive electrode anode. Okay, and then let's consider, do we choose B or D? Again, we're gonna learn in later unit electrolysis. If we use concentrated sodium chloride, there will be something else produced. Okay, so for this one, when we use dilute sulfuric acid, what's going to happen is that the hydroxide in the solution will be attracted to the aluminum object and it will be turned into oxygen gas here. Okay, and that's why aluminum object aluminium would react with oxygen to form the aluminum oxide layer on the object. Okay, but if we change to use concentrated sodium chloride, since it's concentrated, so a lot of chloride ion will be found in the solution, and those chloride ion again would be attracted to the positive electrode. Okay, because negative would like to stay with positive, so it will go to the place that near the aluminum object, and this chloride ion will turn into chlorine gas. So for this part, if we use concentrated sodium chloride, it's not the oxygen that produced to react with aluminium. Okay, it's going to be chlorine that produced here. Okay, so not the purpose of anodization. Okay, so the correct answer should be B. Okay, then we move on. Question 7. Both the flame and gear system of a bicycle are made of steel. So which combination is correct? So for the frame, in order to make it quite cheap and quite efficient, we just do painting, okay? And we can make it look nicer with different color. And for the gear system, because it needs to run smoothly, so we should use oil to do the surface protection. So the correct combination should be A. Okay, so next one, 16. Which of the following combination is or are correct? First one, aluminum window frames. Cathodic protection is possible, but it's not a realistic way to do it. And then galvanized iron buckets, sacrificial protection. Yes, So it puts some of the iron metal bricks onto the bucket, and then it will lose electrons because it's more reactive, so sacrificial protection. The last one, tin-plated iron cans, is not alloy, it's the surface protection. So the correct answer should be B for this one. And for 23, okay, first statement, when iron and copper are separately immersed in hexane completely, iron corrodes faster than copper. Okay, so again, later, I think in the coming 2 units, you're gonna start to learn about organic substance. So this one, hexane, is an organic substance. So this one is also a covalent compound. Okay, so when it's immersed in hexane completely, it would not be able to get into contact with water. Okay, so none of these 2 metals would corrode. Okay, so hence we would not say iron corrodes faster than copper. So the statement 1 is false. And then take a look. Iron can be oxidized more readily than copper. Yes, because iron is more reactive than copper, it tends to lose electrons more readily. Okay, so the answer should be C. The first statement is false, but the second statement is true. Okay, so before I move to short questions, are we fine with all the MC? Type A, okay, if you are all right about the previous questions. Okay, so for the structure questions, again, for most of the questions, you get the idea, but you need to pay attention to your writing, how to write the keywords, and try to use a scientific language to answer those questions. Okay, so the first one, the thin layer of tin prevents iron cans from corrosion. Again, that's surface protection, so it completely it prevents the metal, the iron, get into contact with oxygen and water. Okay, so the answer is attached here. So don't worry if I will post this on Google Classroom, so no need to copy it down. Okay, just go through it with me. And then the second one, explain whether these iron cans will corrode more readily once their surface are damaged by scratching. Okay, a lot of you mentioned that yes, it will corrode more readily because the iron can now get into contact with oxygen and water. But that's not the main reason. Okay, remember there is a thin layer of tin that covered on the surface, and you need to mention that tin is a less reactive metal. Okay, so once it gets scratched, the tin so the iron will actually lose electron to the tin. Okay, so it actually speed up the rusting process. So you need to mention that part. Okay, that's the main reason, not the iron getting into contact with oxygen and water. That's not the major reason. Okay, and for the third one, suggest why galvanization is not suitable. Okay, again, I saw quite a few students write galvanization is toxic. Okay, the process itself is not toxic. And also zinc, okay, zinc metal actually to be accurate, zinc metal is not toxic. It's the zinc iron that's toxic. Okay, so write an accurate answer. Okay, don't write galvanization is toxic. It's not. Okay, and I think I marked some of your 982 parts wrong. Okay, so if I make mistakes, please correct by yourself. Okay, and then part B, why aluminum is more resistant. Okay, so the keywords I'm looking for is impermeable. Okay, because the oxide layer is impermeable to oxygen and water, and also it got that oxide layer on it. Okay, so I'm looking for those two things to give you the mark. And then anodization, all of you got that correct. And then other than corrosion resistance, just one advantage. Okay, a lot of choice that you can mention. Low density, malleable. Malleable, I would suggest not to mention here because we know most of the metal, they are malleable. Okay. And then easy to recycle, easy to dye. Okay, and that's for this one. Okay, and I want to go through this question with you. Question 2. Okay, so question 2. Look at this setup. We got iron 2 sulfate on the left hand side. We have this rust indicator on the right hand side. Okay, and is clipped on a filter paper with some ionic compound, so it can let the ions pass through. And then we connect it to a circuit, and it's a complete circuit. Okay, so first, state the color of iron 2 sulfate. So you need to remember the color for iron 2 ions is green, okay? That's from grade 9. Okay, it's a green color. And then explain what will be observed around the middle of the filter paper when the circuit is closed. So take a look. Okay, when the circuit is closed, let's write out what are the ions appears on both sides. So on the left hand side, we have iron 2, we have sulfate. On the right hand side, we have potassium, we have iron, this. Okay, so when the circuit is completed, remember, positive ion going to be attracted to the negative pole, and negative ion going to be attracted to the positive pole. So you will see that your iron 2, let me use a green color, the iron 2, because it's positively charged, you're going to move towards the right hand side, okay, because it's positive and negative. And then on the right hand side, you got this yellow color Ross indicator. It's negatively charged, so it's gonna move towards the left hand side. And when they meet in the middle of the filter paper, iron 2 together with the Ross indicator is gonna turn into a blue color. Okay, so you need to mention two things. First, you need to mention your observation. You're gonna see a blue color. And secondly, you need to mention why these two ions going to meet in the middle. That's because iron 2 move towards the negative pole, and the Ross indicator ions move towards the positive pole. Okay, so they're going to meet in the middle. So for this one, you're going to consider the movement of the ions, and then you consider, will they have any reactions, or is it just a mixture of the two colors? In this case, they're gonna have a chemical reaction and shows a blue color, okay? And then for the next one, if we switch the two poles of the cell, and then what will be observed? Okay, so if we switch the positive and negative here, and then it's going to be the sulfate ion, which is a colorless ion that moves to the right hand side. And then it's going to be the potassium ion, which is, again, a colorless ion that moves to the left hand side. So both of them are colorless. When they meet in the middle, actually, there will be no observable change, right? Potassium sulfate is not insoluble as well. Okay, so you will see nothing in the middle. So you need to stay your observation, remains unchanged or still colorless. And you need to mention this time it will be these two that migrates toward each other. Okay? And they are both colorless ion and will not form any precipitate. So no observable change. Okay? Is that the last question? Because I think we're running out of time, but I think we will be able to go through all of them. Let me go through them, and if you got question, then just ask me. So next one, question 3. It's kind of repeating what we have mentioned before. So why a galvanized iron object does not easily rust? So because zinc is more reactive, it's a sacrificial protection method. Okay, so this one, I think most of you get it. And then why anodization can prevent aluminum objects. Again, I'm looking for the keywords that it has an aluminum oxide layer. Okay, remember to write the keywords. And also, it's impermeable to water and oxygen. Okay, remember to use a scientific language. So you can say it's impermeable to oxygen and water, or you can prevent the iron from getting into contact with water and oxygen. Try to avoid saying it blocks the oxygen and it blocks the oxygen and water is okay. I try to say it cannot meet oxygen or water, right? It's not wrong, but it's not scientific. Okay, so try to use a scientific language. So the last question here. The first one, most of you get it. It should be blue and pink. Okay, and part B. Okay, most of you mentioned C will not rust. Okay, because it's covered with oil, so it prevent getting contact with water and oxygen. So quite obvious. But you need to also mention that B, which is wrapped with magnesium ribbon, will also not corrode because magnesium is more reactive. So that's sacrificial protection, or you will lose electron more readily than iron. Hence, iron would not rust in this condition. Okay, that's the end for Unit 13 exercise. So any question for me? So after after this meeting, I will post a video and also the model answer online. So please correct your answer and upload your correction for checking. You don't need to really print out my marking if you already got a hard copy of your own one. So you can just write the corrections on your own copy and take a photo. Try to make it into a PDF file and try to make it into one PDF file so it would be easier for me to mark. Okay, any more questions? And I believe by tonight I will be able to return your Unit 14 exercise again, so take a look first before our meeting tomorrow. Okay.